Hello, my name is Junichi Kanebako. In this presentation, I will introduce the background to and concept of our work, Sympathetic Wear, in addition to its technological, haptic, and fashion design aspects. This project took place entirely remote from two locations, Kobe and Tokyo. Discussions, prototyping, and experiments were conducted remotely, and the work was produced through an online collaboration. During discussion about the concept, we spent a lot of time considering how feelings could be conveyed beyond words through the digital screen. In situations where people cannot communicate face to face. Since interaction through the screen is based on the visual and auditory communication centered on the face, we focus on the human back as a means to supplement communication. Since one cannot see one's own back, we can find various idiomatic expressions that refer to the back as a part of the body that can sense the presence or gaze of others. Many of sensations of warmth people experience from others, such as a familiarity felt when embracing as a greeting or in times of grief, are often received through the sense of touch on one's back. It is a Japanese word teate, signifying to treat, among other meanings, has its origin in the healing effect obtained by applying one's hands, while responding the tenderness and the other feelings that can be experienced through forms of touch, such as hugging and handshakes, and applying such function to clothing worn on daily basis, we thought it would be possible to sense the warmth of others through our garments. Fashion designer Yoji Yamamoto stated that fashion is compassion towards others. Inspired by this statement, we decided to create a garment that would help people communicate with others and promote mutual understanding and compassion. The human sense of touch is classified into three types: vibration, temperature, and pressure. While there are various precedents for producing stimulation on the skin, it is difficult to convey the sensation of having one's back struck smoothly using a sense of a vibration or temperature. Believing that the sensation of pressure is most effective way to create the sensation of the back being struck, we examined how best to implement such a sensation. Compressed air is often used as a means of simulating the sensation of pressure, but it is difficult to simplify such a system due to necessity of using pipes to transmit the air. Since we wanted this work to eventually be available in every setting, we need to consider other methods. The material we used, biometal SMA, has a property of contracting when the voltage is applied. We thought that if it was possible to press this in a plate-like a material, we could simulate the sensation of pressure through the bending of the plate when the biometal contracts. However, the problem is that while the torque of biometal is strong, the rate of expansion and contraction is low. If, for example, voltage is applied to a 100 centimeter pieces of biometal, it will only contract by approximately 4% or around 4 centimeters. Therefore, it was a necessity to efficiently arrange the long lengths of biometal in order to cause a large contortion in the plate. We went through the lengthy process of trial and error to find the best SMA wiring pattern to achieve the pressure producing module expanding leaf. The initial prototype achieved only a small contortion in the plate. Next, we altered the wiring pattern in order to use a long length of SMA, creating a layout that used around 86 centimeters in a single plate. In fact, when the SMA was pressed on the back and the motion activated, only a little pressure was felt with a single plate. So we changed to use of two modules grouped together with acrylic and activated simultaneously. Since the modules are made using an SLA 3D printer, they can be made in the various sizes based on the design data, and the pressure over a wider area becomes possible. Considering the efficiency of producing a large number of modules, we attached SMA to the plate using a hook-like design. Finally, we created an iPad application that drives the modules. By touching the back icon display on the iPad, corresponding module begins to move at a certain speed, and the pressure is applied to the back of the wheel. The next question we examined was which area of the back should pressure be applied to in order to efficiently convey the sense of pressure. A prototype taken from the t-shirt with pockets on the back was used and tested with a module pressed in the pockets. We refer to dermatomes of the back to determine the vertical spacing of the pockets. To create the sensation of stroking on the back, we apply the rabbit step as a tactile illusion. A rabbit step is a phenomenon in which, if 2 points about 10 cm apart on the receiver's skin are tapped lightly in succession, the receiver feels a movement like a rabbit step on the skin between the 2 points that were tapped. We thought this phenomenon could be applied, for example, by activating 4 modules pressed on the back in sequence, thus evoking a tactile sensation at intermediate points that could cause the receiver to feel though their back is being caressed. After determining the placement of the device by examining area where pressure could be effectively produced, and after demonstrating technical viability for our method of creating the illusion of stroking on the back, we finally decided on the textile design. The garment is produced using a makrame technique. Derived from the Arabic word mikrama, embroidered bead, makrame means to cross and tie, and is a technique to use to create various shapes by tying thread together. Makrame involves tying each thread by hand and cannot be mass-produced by machine. The meaning of crossing and tying through the human hand expresses the idea of connecting people who care about one another. The material used is a thick wool yarn, which was hand-knitted using a makrame techniques but also fringed at the various points. By creating several fringes, we gave a sense of awareness contained between the thread and the visually expressed the image of being wrapped in warmth. Pockets are provided for the module on the back of the garment, for which warm chords were used to express the feeling of the gentle stroking. When we asked the module to the wearer to wear the work for the video recording and experiencing it for themselves, they commented on how surprised they felt the real sensation of having their backs caressed. The aim of our works is to bring in greater tenderness to our daily lives by deepening relationships between us, expressing feeling of closeness, compassion, and engagement through the human back. The viewers' comments and the natural expression on their faces during the video recording serve to affirm the embodiment of our concept. In the future, so we plan to develop this garment into the clothing that can be used easily in daily life through the use of microcomputer with a wireless communication capability that allows it is connected to a network. We also intend to increase the capacity for mutual communication through the human back by developing more modules in the garment. In terms of know-how of production amidst the COVID-19 pandemic, we think this project serves as an example of possibility of remote collaboration. We believe that production carried out entirely through online communication can be realized as long as concepts are shared through in-depth discussion and prototype rigorously communicated. Based on this experience, we would like to collaborate with people all over the world to create new worlds in the future. It is difficult to convey the sensation of having one's back stroked using words alone, so we hope you will experience the work at the exhibition. Thank you for your kind attention.